Okay. Hi. My name is Markus Levy. I'm president of EEMBC, which is the Embedded Microprocessor Benchmark Consortium. We started up about 18 years ago, where we were really focused on microprocessors, and now we've expanded. We're starting to do benchmarking for Android devices. And the reason I'm standing up here now is because we are launching today the beta version of our server benchmark suite. And actually, your question, the guy in the blue shirt there, is a perfect segue into the problem that we face, because when you're developing benchmarks, or I should say, when companies are representing their products, they mostly use inflated marketing performance ratings because they've tuned the system, take Memcache, for example, they've tuned the system to find the best parameters that's going to give them the optimal results. Of course, they don't publish all the details, and they just say, okay, here's our latency, here's our throughput. And the biggest goal that we do at EEMBC, which is not necessarily rocket science, but it's a standardization process where you ensure that everybody who's running this test is running it with the same set of parameters so that you can more or less compare apples to apples. But of course, you know that when you're trying to compare either SoCs for servers or the servers themselves, it's really complicated, right? Because there's so many variables, especially if you have not just the SoC, but you have the I/O, and what's the disk performance, and what's the memory performance. And so there's a lot of trade-offs, which makes it still difficult to compare apples to apples. But at least what we try to do at EEMBC is come up with the fundamental methodology to make sure that everybody installs it the same, to make sure that everybody runs it the same, using the same parameters. But it still has the flexibility. If you want to play with it, you can do that. But still, it's...
Just get those full screen, I'm sorry.
Oh, yeah, actually, that would be great if you can. Thank you. Yeah, so I'm co-presenting today with Ryan. Ryan is from Cavium. And he is one of the chairs of this working group within EEMBC. And of course, many of you know Cavium, been in the networking industry for a long time, building SoCs for networking, and most recently is the ThunderX product line, which is ARM 48-core devices targeted at the server market. So they have got a lot of experience in this server area and helped out quite a bit. So I kind of gave a little overview of what EEMBC is about. We have 47 members, lots of commercial licensees, and we've been doing this for 18 years. See all the gray hair from working on this stuff? It's still fun. All right, so the key characteristics, by the way, our benchmark is called ScaleMark because it's supposed to represent the scale-out server market. Well-defined parameters, automated install and build process, and this is always a tricky thing. And I'm sure if you guys are doing testing right now, and you might have seen other benchmarks out there like Google's Perf Kit, it's a good collection of software, but it's important for us to put all the pieces together in the right way so that we don't have a whole lot of support issues. And installing this stuff needs to be really simplified and almost to the point of cookbook so that companies, people who use it don't just say, oh, this is a useless thing, too much work to get it to run. Plus getting it to run on an ARM server, on an Intel server, on an IBM open power architecture. It has to be portable across all these different architectures and system configurations. And of course, another big issue here, that nobody wants to run benchmarks on a full data center. So it has to have some representation of what the cloud is going to look like, but running only on one or a few nodes. So we're doing a phased rollout, starting with some standalone workloads. And I'm kind of jumping ahead, and I'll conclude with this as well, is that the beta is available. Actually, we finally closed it up Monday. And if there's anybody here who's interested in being a beta tester, we'd love that. And hopefully we've simplified the process so we're not asking too much. Actually, this is pretty close to what I almost consider to be a release candidate. Put a lot of energy to make sure that people had a good experience with the beta version. So if you're interested, talk to me afterwards or email me. That would be great. So what we're starting with here is a memory caching analysis benchmark, which of course you know is popularly called Memcache D. And the key thing here is the specific parameters that we've defined. And so in doing this analysis, we use parameters that did not intentionally make the server look great or make the server look horrible. And the members that are participating in this right now, of course, Cavium, Intel, AMD, Qualcomm, who else? I'm missing somebody. Okay, somebody else. And so it was quite a long debate. Coming up with the actual benchmark was the easy part, but I think the group debated for months on which parameters to actually use. The goal here was to try to find something that was real-world representative. So from a standardization perspective, we standardized on the server code base. We standardized on the load generator. And actually, this is another interesting challenge in developing benchmarks, is you're not just developing code that's running on a server. You're also developing a set that will run on the clients or simulate clients running, because you have to have the client-server interaction. And that is also a pretty challenging aspect of doing this. So this here is just a list of some of the parameters that we have standardized on. So the IA distribution, set-get ratio, the number of connections was a really key factor. And Orion's going to talk to you about some of the results that we saw and why choosing the correct set of parameters is important. Okay.
Thanks, Markus. As Markus said, I'm Narayan Iyengar. I'm a software engineer at Cavium, and we've been going back and forth on this for months as to why choosing certain parameters matters. So we chose Memcache D because that seems to be what a lot of our customers seem to run. They want these Memcache D numbers. They want queries per second at a given latency, and that varies from customer to customer to customer. And as you can see, some of the workload parameters that we've standardized are the number of connections that the server gets, the key value size and distribution, the inter-arrival gap distribution, and the get and set ratio. So we ran a lot of tests across a lot of different platforms, and you can kind of guess what the platforms might have been. And what you see is why choosing one specific set of parameters is important. This graph kind of represents the queries per second versus the number of connections on multiple different servers. And depending on what you tweak, for example, if you do no updates and just use 32-byte value size, you can see the blue line all the way up at the top. It has a different performance characteristics as the number of connection changes versus if you just change the update ratio. So after a lot of debate and a lot of back and forth and a lot of data collection and analysis, we decided to standardize on the number of connections, 2 different sets of number of connections, and what the update ratio was. And to help us, we kind of relied heavily on this paper that was done in 2012, presented at SID Metrics by a bunch of guys at Facebook. And what they noticed was they had several different sets of pools of data, and they chose this, what they call this etc. pool of data, which seemed to represent very real world, KVS values. Lots of fancy graphs. Kind of what this shows is based on all their analysis, the distributions that they chose. You can't really see it here, or you can't see it up here. The blue line that represents, that's the distribution values that they've chosen, that we have chosen in the benchmark, and the red line is the actual real world characteristic of the data that, So the other question is, why does client configuration matter? We have standardized certain things on the server side, but why does a client configuration matter? And here is a few different clients running the exact same workload, and on the bottom, if you just vary the number of connections, or the same number of connections, just vary the number of threads, you can see you can see a huge variation in the throughput. And these little dips that you notice all the way at the bottom here are client bottlenecks. So we want to make sure that the numbers that we chose, as Markus said, that we don't want a server to look particularly good or particularly bad given a set of parameters. So how do we do this? Very simple configuration. We have, in our lab, we had 4 different client machines that were very identical, a dedicated 10 gig switch, and then we just varied the server over and over again to collect different numbers. Server source built with GCC, running Ubuntu, and in cases, right now I'll show you data that has 2 different servers, and they were running 4 instances of Memcache with 10 threads per instance. And we use this client generation tool called Mutilate that is extremely well written, and it is able to coordinate between different client machines and give one set of results. So here you see throughput comparison for 2 different servers, the purple machine and the green machine. And as you can see, depending on what I choose, either the purple machine is really good or the green machine is really good. So if I was in the marketing department, I could easily show, and if I'm representing the green machine, I can easily show that, hey, you know what? Our machine kicks ass at 1536 connections as opposed to the purple machine, which is our competitor, versus ignoring the 2048 connection part at all because the purple machine is better. So we kind of did not want this scenario where you are able to kind of fudge the numbers, and at least with this benchmark. The marketing guys will do what they want to do to sell it, and that's unavoidable, but we don't, as far as the benchmark is concerned, we didn't want this to happen, to say we just give you one number, we're not going to mention anything else about it. The second is to set some sort of bar, especially for Memcache, where you say, hey, here's a bar for a throughput at a particular latency. For instance, here, it doesn't really matter if how bad or how good you are above this 1 millisecond latency bar. It just matters that at 1536 connections, both servers are really good, and they are well within the 1 millisecond latency. Now you can just compare the throughput numbers. Similarly, at 2048 connections or 1024 connections, you can see that, yes, my green machine is not able to do 1024 connections at 1 millisecond latency. It doesn't matter what the throughput is. At that point, you can easily compare results without having to say what is the latency or it's this throughput at this latency. You just know that when you're running ScaleMark, you get this number at this latency. So just kind of in brief summary, both servers get the best. We noticed that both servers had hit the sweet spot at 1536 connections. The standard value that we chose for now, and this is an evolving number, and both servers did very well under 10 millisecond latency. And it is very, very crucial to test under the exact same conditions so that you don't hit a sweet spot or a sore spot for a particular server. And the key thing to point out is there was no optimization that was applied to Memcache in either of these instances. The green machine and the purple machine just ran, just a standard version of Memcache that we just, downloaded and compiled. Why we're here is we need more beta testers, and we need people who really understand the big data space. As Markus said, a lot of us are silicon vendors, and we're looking at these workloads from one perspective, but we need people who know systems, who know the big data space really well, and help us kind of define the next phase of workloads. We want to keep these workloads as realistic as possible so that if we were to compare the green machine and a purple machine, it's not just some cooked up synthetic benchmark. It actually represents a real world use case. And somebody like a service provider or a customer can look at it and say, oh, I understand this is what you're trying to do. And it really fits well within what we do in a commercial product. And obviously we want to use the EEMBC standards to guide optimization efforts that will help in these kinds of application deployment. That's all I had. If you guys have any questions, I'm here. I know it's lunchtime, and so I wanted to keep it quick. Oh.
I got one.
Oh, it's European lunchtime.
Hello, this is.
Turn off the switch.
Hello.
You're live.
Hi. So the question I had was the echo, the latency, worst case latency you had there in the benchmark. So you put a high watermark of 10 milliseconds, and you're saying most are within 1 millisecond. Can you talk a little bit more about the reason that you determined that? I'll give you my thought as to why I think that matters. A lot of these key value systems in the ARM space are going to go into these kind of public cloud vendors. People are building. I was just checking while you were speaking the requirements for the real-time advertising bid systems that are out there. Right now, the hard requirement there is to have an answer within 50 milliseconds, and that might involve multiple queries. So I think 10 is high, and I'm curious to know what the calculus was going into that.
Yes, 10 is very high, and we knew 10 is very high, but we did not want to set a really aggressive watermark because without going into a lot of the details that people reveal in these working groups, there were a few instances where potentially one was too aggressive to start off with. So that's why, after a lot of debate, we said, okay, to include everybody in the working group so that.
That's the problem. You try to include everybody, then you end up.
Yeah, so believe me, we struggled with this quite a bit as to why 10 millisecond, and a lot of guys from ARM have been very vocal as to 10 millisecond being high. But do you want to?
So can you make me live here?
Well, you're live.
I am. I think the main metric that we're looking at here is QPS, and so the idea was that if anybody went above 10 milliseconds, that the test would fail. So the idea was not to fail people, but to still produce a QPS, because some people, actually we've run this on a laptop, the Memcache part, and so I don't know what the latency is going to be there, or we've also run it on AWS, which is going to be slow because you have the connection to the internet and stuff. So the main goal wasn't really if you were way above 10 milliseconds or above 10 milliseconds, then it's way too slow. It's not realistic at all. But it's more a question of just pass-fail on this test.
And to add to that, this is evolving, and as more members join, and that's kind of why we're going out and pitching this benchmark to say, join us and help us, kind of understand why 10 millisecond is too high, and what should be the benchmark that we should aim for, that the watermark that we should aim for.
I'm very much a friend here, right? So the reason I care, though, is I want more of these benchmarks. So I was chatting with you guys a couple of years ago about this. I'm really happy that it's out today. That's wonderful. But I don't want us to get beaten up that, that benchmark, this part of it. I mean, the benchmark's great, but this particular component is, well, no one's going to actually have a situation where they do that in reality because they need to have a higher level of dependency there. So I'm just capturing it as something that I would hope would swiftly change.
Every meeting we address it.
Okay.
And when we're trying to get to a point where everybody kind of agrees that, yeah, we have to hit a lower watermark for latency. Yeah.
And by the way, it's a great comment, and this, as I said, this is a beta right now. So it's not closed, and we haven't published anything officially, no results or anything. So it's a good time. What's your company? Red Hat. Red Hat, okay. So I mean, actually Red Hat's a member of EEMBC. Yes, we are. So, you could join the working group meeting, put in your 2 cents there for the guys, and change these parameters. I think, it's hard to get it all right. And so right now we have about 6 or 7 companies, or a mixture of universities and companies that have signed up initially to be beta testers, including HP, and there's a Korean university and somebody in Greece and a couple others. So I'm hoping that we can get some feedback from those guys as well on this. Yeah, okay, cool. And by the way, those bar charts that he was showing were based on some real systems, but unfortunately we weren't allowed to say publicly what they were. But if you want to know, you can talk to Narayan afterwards, and he'll let you guys know which one was which.
Any other questions? Yes.
I'll just shout. How long does it take to run the whole test? Minutes, hours, days?
On a real system or on a simulator? I don't know. How long does it take?
The Memcache test is, there are configurable parameters. You can tweak it to say, I want it to run it for 60 minutes, or I want to run it for 60 seconds. I think it runs 3 rounds of it, maybe 10 minutes each or something like that. I don't remember. Yeah. This is one benchmark that is Memcache. We are currently trying to finalize or make beta on a media streaming benchmark. That will be a different set of parameters, and it'll run for a different set of time depending on how many files are being served, how many clients are being served. So there's a lot of debate. Everybody has an opinion on media streaming. That is the idea. That is the idea. Honestly, I don't want to launch a benchmark and come back 2 days later and say that it's still running. I want it to be done maybe half a day, so I can at least, Yes. Yeah.
Yeah, and that's another point too. So we've separated all the workloads in here. So Memcache is the first one, then media streaming, and then we're working on the future as well. But we also figure that maybe only in certain communities will people want to run all of them, but most companies will just want to focus on one piece of it. And so you can run it completely independent and get a score. It's not going to be a lump aggregated score at the end.
And you obviously drop caches and reboot. It's a cold start, right?
It's a cold start?
That's defined, right? The process for each cycle.
Currently, that is not defined. Yeah.
That needs fixing.
Yeah.
Where
Again,
were you?
this is.
My guys didn't tell me that that's a fair.
Yeah, I know. It's a big world, so it's hard to know. Yeah, sure.
That is a very good point. And and we do that manually just to do a cold start, but we haven't necessarily imposed the restriction that you have to reboot within each run. Yeah.
Any other questions?
Join the working group, please. Yeah.
I'm really on the wrong side of this all.
Yeah, Reddit's been a member for at least a decade.
The big boy voice.
Yeah, I just had one quick one. For that 10 millisecond latency, was that average or 99th percentile or 99.9 percentile or what?
Oh, that's a good point. It's 95th percentile under
Okay.
10 millisecond latency.
Yeah. All right.
So.
Anyone else? All right, if we could, let's please give a good hand of applause.